Hello and welcome to Noel's RetroLab. I got the parts that I was waiting for in the mail, so it's time to open up again this TI-99 4A and see if we can get it working. If you remember from last video, which unfortunately was a while ago, I apologize, we couldn't get the board to work. We were getting that repeated sound that we saw in the oscilloscope. And my theory was that it wasn't getting very far along in the bootstrapping process. And it looks like maybe even like the first read from the ROM was just not working and it was just stuck in that loop trying to repeat that over and over. And when we look at the data bus, looked suspiciously bad. Several lines were permanently stuck in high and low. And so my theory at the time was like, well, the first thing we're trying to do is, read from the ROM. So maybe there's something wrong with the ROM. So I need to get some EPROMs because these are DIP24, which are not particularly common EPROMs. And here they are. We have some that we could use. Okay, let's check the data bus without even putting in the new EPROM, which we haven't even burned anyway, but let's try it anyway, just to see if something else is driving those pins, and there's nothing there, nothing there. Okay, so we are getting nothing on the data bus, which it's probably good because before they were going high and now we removed this and nothing is bringing them high. So maybe the ROM chip was faulty after all. So I think it's worth burning an EPROM with the ROM contents and trying it on again and see if that improves things any in the bus. The TI-99 4A has two system ROMs, each of them containing 4 kilobytes. If you remember from last time, the CPU accessed them in parallel, reading a 16-bit word between the two at the same time. The ROMs have 24 pins, and the closest EPROM matching that pin out is the TMS2532. Unfortunately, I have two problems with that. One, it's hard to find a TMS2532, and two, my EPROM programmer doesn't seem to support those. However, we can use a TMS2732A instead. It's also a 4K EPROM, and it has almost identical pinouts except for a couple of pins. Let's start by burning the right data on it, and then we'll make an adapter and use it in the computer. So there are actually two different ROMs, one for the lower data bus, and the high data bus. So we want the high one. This is the one that we're replacing right now. If we have to replace the other one, we'll have to burn the other one. We have the right chip selected. Let's burn it. Oh. Okay, let's try a different EPROM. Maybe that one was bad. And again. So I tried all of them and they're all failing. So I even went ahead and got the latest version of the EPROM programmer software, just in case something had changed with the support for this particular EPROM. And nothing. Every single time I try to program it, I get a slightly different error now, but it's still an error and it happens right away. So there are actually two potential problems. One of them is I was looking at the data sheet, and I think that to program this particular EPROM, you really need 21 volts. And this particular EPROM programmer only goes up to 18, which is particularly frustrating because an earlier version of the same one went all the way to 21 volts. So that's very annoying. So the other potential problem is that I'm not convinced these are authentic 2732As. And, they have this weird sort of two-level construction, which apparently was correct, but they feel really rough. I mean, it really feels like somebody just machined these down. And to make that worse, if you compare some of the ones that came in the same batch, they have completely different dies. This has like two smaller dies. This has one big one. And then I've seen pictures of what are supposed to be original or authentic 2732s, and they actually have even much smaller dies than this. So yeah, I'm not sure we'll be able to do anything with those. So that was a disappointment, to be waiting all this time for those EPROMs and then not being able to really program them. So instead of stopping here and trying to get some new ones, what I'm going to do is I'm going to try to use a different kind of EPROM that I know I can definitely program, and we'll just have to make a slightly bigger adapter. What I'm just going to do is use this very standard 27128. So this is a 16K EPROM. The fact that it's 16K is not a big deal. We can just save the same data 4 different times, so it uses up all of the ROM. The problem is that this is a DIP 28 instead of a DIP 24 like the other one, but I was going to have to make a little adapter for the other one. I'll just make an adapter for this one. It's just going to be very slightly more complicated, but at least I know I can reliably burn this one. So let's go ahead and do that. So the first thing we need to do is create a 16K image with the ROM duplicated 4 times. So I'm just going to concatenate it, and we need to make sure we use the upper ROM. So the high, okay. And just do that 4 times. And I'll just send that to ROM high bin. Okay, and now we can burn that one. I need to select the right chip, load the ROM that we just created. So this is 16K ROM. And now let's write it. Okay. That seemed to have worked. Initially, it may seem difficult to make a 27C128 EPROM work in place of a TMS2532, but apart from having 4 extra pins, they're actually surprisingly similar. In particular, if we align the bottom of the 2 chips, most of the signals are in the right place already. The numbers may throw you off because the count is different because of the 4 extra bits and that we count counterclockwise, but we just need to make a couple little changes. We need to swap out pins 20 and 23 on the 27C128. We need to set pins 1, 27, and 28 to VCC or 5 volts. And then we're just left with A12 and A13. Since this is a 16K EPROM, it's normal that we have 2 extra addressing bits. In this case, we can turn them either high or low. It doesn't matter as long as it's consistent. And since we have VCC right next to them, we can just connect them both to 5 volts, and that's it. So the idea is to be able to put this EPROM that we just burned on this socket with a few connections. So for that, we're going to use this intermediate 28-pin socket with the connections we just saw. And in order to solder this, I'm actually going to change the tip of my soldering iron. I usually like to have this wide chisel tip, but in this particular case, because we're going to be getting to some very small, fine points, I'd rather use a sharp point. Like that. Okay, so the very first thing I want to do is connect the pins that are going to be hanging over to VCC. So those 2 and those 2, and conveniently VCC is this one. So with a single wire, I should be able to connect those 3, have it come over and connect those 2. I'm also going to cut them a little bit so they don't bother us. And I'll tin them now. So it's a little bigger than I was hoping to make it, but that's all right. I can probably just push it in as well, like that. And then we need to put two little cables in pins 20 and 23. 20, we'll cut it. 21, 22, 23. Also cut it. And somehow I missed turning the camera on right as I was doing this, but it was just a matter of putting this cable on pin 21 and this one in pin 18, and I soldered each of them. And now we just need to put these two together, and that should be it. If we want to make sure that it really stays in place, we can try adding a little bit of solder. Another reason to add some solder to this is to make sure that those pins are not touching with the bottom one. So you can just leave the socket a little bit out and solder it in place so it doesn't move and it makes good contact. And it's always a good idea to check that the connections are the way you expect and that there are no shorts, because, you know, this is not the prettiest thing. So this should all connect like that. Except for this one. This one should be here. Okay. Oh, I missed that one. I probably couldn't solder that one very well. This one should be here. Yep. And that one is missing as well. Okay, so we have a couple of them not making correct connections. Okay, so I checked continuity and I fixed a couple more pins and everything is connected the way it's supposed to be. So let's try it out now. That's quite the stack now. Let's start having a look at the data bus, see if we see some activity now. I'll just randomly grab this one. Okay, we see some, we saw something and then it went away. What? I get the chip select or output enable. That's on high. I'll turn it off and turn it back on. Okay, so it looks like it's doing something for a little bit. I'm gonna get this one again, another data bit. Yeah, we see something and then boom, gone. Yeah. Actually, no output enable. What about the output enable for the static RAM? Nothing now, but I'm gonna turn it off and on. Before, we didn't used to see anything on the static RAM. It never got to it. It was trying, the CPU was trying to read from ROM and it never got as far as to start writing some things to RAM. And now, okay, there's some activity there in the RAM. Now there's some continued activity. Okay. Okay, so now there's some activity on the data bus, but that looks pretty bad. That's almost like a sign that somebody's trying to output something to the data bus and is being shorted to ground. And is this part of the ROM? No, so right now we're not trying to do any ROM reads. And it looks like the static RAM is... Okay, so now it just stopped doing any activity. Okay. So that looks fine. That looks totally fine. And we have some output enable on the ROM. And we have some output enable on the RAM chip. So it's like now it's suddenly working. That's still rather ugly. Some taller than others. I mean, it could be the difference between the output of the ROM and the RAM. But at least it's doing something now. What about the sound? Let's do it quickly before it crashes. Sound used to be right here. What do we have there? Yeah, that still looks like there's a sound happening. It's different because this one goes up and down. Definitely different than what we had before, but it's still there. So something is not starting up correctly on this computer. Now the ROM is definitely better. This was definitely an improvement. We are seeing some activity in the data lines. We start some activity on the RAM chips, but something, so I mean, it could be a bad ROM that, maybe this one is also damaged, and so it starts executing kind of random code until it hangs. It could be bad RAM. It could be something else. It could be the CPU. I mean, at this point, it could be almost anything. And it doesn't seem to be repeatable. Sometimes it runs for a while. Sometimes it seems to stop right away. Like, is it still running? Yeah. Oh, this is very, very symmetrical now. So clearly a very different pattern. And that's the part that looks a little weird to me. That seems like there's some fighting in there. Okay, so now we're not doing any ROM reads. It's all purely DRAM. And this is not a consistent pattern. And if I turn it off and on again, yeah, we're still getting a continued data stream. But at the beginning, it was just stopping right away. Yeah, there you go. That was ROM enable. Started up, boom, stopped right away. And not even RAM, so now we're getting a dead data bus. Yep. That's discouraging. So I noticed a couple more things. So for example, if we look at the output enable of the static RAM, and we catch sometime that is actually working. Wow. Now this time this is, there we go. And we zoom out. It's not happening now. It was happening before. I was getting some weird over voltages, like going all the way to 6 volts, which was really weird. A little bit like that, but more. It was very clearly going all the way to 6. And that comes from an OR gate down in the board. So it doesn't make any sense that it goes over that. And then the write enable also looked weird when I looked at it earlier. So that's 16. Yeah, look at that signal halfway hanging there. And this comes straight from the CPU. So there are no other intermediate chips. So it sounds to me that the RAM or the CPU is bad. So I think what I'm going to do is I'm going to desolder them and socket them, remove them completely, and see what we see in that write line. And if it's still halfway there, we'll know the CPU, assuming the CPU even gets as far as generating that, we'll see that we'll know that the CPU needs replacement. If the signal looks good, then chances are it was the SRAM and we just need to replace that. Okay, so I desolder the static RAM and put some sockets while you weren't looking. So we're all set for the test. Let's turn it on and let's see. That's the chip enable. So that's fine. And then the write, yeah, so now the write signal looks totally fine. It's not that weird intermediate one. And what does the data bus look like? I guess looks kind of messy like before. So that's interesting because now there goes my theory that some of those signals were the RAM and some were the ROM because the RAM is not connected. So if so, those signals are coming from elsewhere in the bus. But, we have activity. Let's see, that's the ROM output enable. That's the one. That seems fine. And it doesn't halt like it did before. So I'm going to say that probably either one or both of the static RAM were bad and we should get some replacements. Once we get everything working, we can always try fitting some of the original ones back in and see if those were really defective or not, but this looks a lot better without them. One last thing, let's see if we can close the RF shielding. And yeah, this is what I was afraid of. There's just not enough room for the stack of those sockets and the EPROM. So yeah, we have 3 sockets plus the EPROM on top. So I'm going to remove the bottom socket because we don't really need that and solder the second socket on the board itself. And hopefully that gives us just enough clearance to put that shield back on. So there it is. I removed one of the levels. And now we can put the EPROM back. And let's see if we can close it now. So it looks like it's touching the EPROM, the top, just barely, but that's fine. I don't think this is going to prevent the case from closing. So hopefully that's good enough. So we are making some progress. It's definitely the ROM is better than it used to be, and we've identified that the static RAM seem to be definitely bad given those signals. So now we need to wait for those to arrive. Now I've ordered them from a source in Europe, so they shouldn't take as long as the EPROMs did. So we should hopefully wrap up this series in a few weeks. Anyway, I hope you enjoyed the video. If so, please give it a thumbs up and subscribe to the channel. Until next video, see you then.